Module Overview. In the journey toward professional realism, mastering color theory and its practical application is indispensable. While form, value, and composition lay the groundwork for realistic artwork, it is color that breathes life into the static. In Module 8, you delve into the science, psychology, and emotional resonance of color in the context of still life realism. This module explores advanced color systems, pigment properties, harmony principles, color temperature theory, optical mixing, and the subtle use of local versus perceived color in realistic renderings. It also covers the relationship between light and color, the way objects reflect and absorb different wavelengths, and how artists manipulate these phenomena to achieve lifelike outcomes. 1. Scientific foundation of color. The nature of color. Color is not inherent in objects. It is perceived due to light reflection. An object appears red because it reflects red wavelengths and absorbs others. This module begins by addressing hue, pure color, red, blue, green; value, lightness or darkness of a color; chroma, saturation, intensity or purity of a color; key, theories, additive color theory, RGB, relevant for digital applications; subtractive color theory, RYB and CMYK, relevant for pigments and paint mixing. 2. Pigment behavior and material properties. Pigments in still life realism must be chosen based on their opacity, tinting strength, granulation, and permanence. 1. Pigment type 2. Characteristics. 3. Best for cadmium. Red opaque, vibrant, strong tint, warm tones, focal objects; ultramarine blue, transparent, granulating shadows, cooler environments; burnt umber, earthy, warm, fast-drying backgrounds, aged surfaces; viridian green, low tinting, cool transparent reflections; metallics. Glass understanding pigment behavior allows artists to manipulate realism by rendering surface quality, light response, and shadow depth. 3. Color psychology and emotional resonance. Colors in still life realism evoke emotion and narrative subtly. Warm colors, red, orange, yellow; energy, warmth, urgency. Cool colors, blue, green, violet; calm, mystery, detachment. Neutrals, gray, brown, beige; balance, grounding, realism. Example: a bowl of fruit painted in warm tones under cool light creates visual tension and emotional intrigue. 4. Color harmony systems. Understanding how to arrange color relationships improves visual balance and unity. Harmony types include monochromatic, one hue, varied in value and saturation; analogous, colors adjacent on the color wheel; complementary, opposite hues, e.g., blue/orange; split, complementary, a base color plus 2 adjacent complements; triadic, 3 evenly spaced hues, e.g., red, yellow, blue. These systems form the compositional foundation of professional still life arrangements, helping the artist to control rhythm, contrast, and focal direction. 5. Material-based light behavior. Different surfaces react to light differently. 1. Material 2. Highlight 3. Shadow 4. Surface qualities. Glass. Sharp, bright, subtle transparency, reflections; metal specular, mirrored, harsh; high contrast, crisp edges, fruit soft, wet midtone, subtle gradation; wood diffuse, warm, absorbs light softly; fabric broken light, deep folds, soft shadows, high detail. Realist artists must internalize how light interacts with materials to paint them convincingly. 5. Color temperature and realistic impact. Realism requires nuanced temperature shifts: cool shadows, warm highlights in daylight; warm shadows, cooler midtones in incandescent or evening scenes. Advanced techniques include modulating temperature within a single object, using temperature contrast to push or pull objects in space, employing optical color mixing to suggest atmospheric depth. 6. Local color versus perceived color. Local color, the actual color of the object, e.g., banana equals yellow. Perceived color, The color is affected by light, surroundings, and mood. A banana under blue light may appear greenish. Artists must train their eyes to paint what they see, not what they know. This means observational discipline. Subtle color layering breaking symbolic assumptions, e.g., apples are not always red. 7. Glazing and layering for depth. Old masters achieved luminous realism via color glazing, applying multiple transparent layers. Letting light pass through to reflect from lower layers creates the illusion of depth and realism. This technique is critical in painting glass, skin, fruit, cloth, and more. 8. Contemporary approaches. Digital versus traditional color. Digital realism uses RGB blending with transparency tools and layers. Traditional realism depends on mixing, drying times, and material absorbency. Artists must adapt techniques while retaining core color theory principles.